night shift site reliability engineer named Maria Camacho watched a simple DNS query spin, stall, and fail on a screen in a windowless operations room in Northern Virginia. 2 tabs over, a U.S. East Coast hospital's electronic records flagged auth timeout. In Slack, someone typed us East 1 and hit enter. In less than 4 minutes, status dashboards turned from green to mottled amber. Health checks drained, then flared red. The graphs looked like a heart missing beats. 20 hours later, an unrelated live stream from an amateur observatory in Chile cut to a diagram of Earth's orbit and a bright orange disk, the Sun. In a calm voiceover, the observer explained that a recently designated interstellar object, 3I/Atlas, had entered solar conjunction, which meant, from our vantage, it had slid behind the Sun telescopes would lose it. For days, possibly longer. 2 disappearances in one news cycle. A cloud region faltered. A visitor from between the stars hid in the sunlit glare. The first touched services you used before coffee. The second touched something older. Curiosity, unease, the ache of not knowing. They were separate events. Yet feeds stitched them together. Threads of coincidence or cover-up. Dashboards overlaid with sky charts. The question rose anyway from engineers, astronomers, and people just trying to check a lab result. Why did we lose both windows, our digital one and our celestial one, almost at once? For a parent in Baltimore, it meant a portal logged them out and delayed a pediatric televisit. For a postdoc in La Silla, it meant a quiet dome, an offline pipeline, and a comet-shaped enigma somewhere behind the sun. For newsrooms and think tanks, it meant a long night of correlation, context, and restraint. This is the story of 2 blind spots, one engineered, one orbital, and the long week that followed. How 3I/Atlas became a Rorschach for meaning. How a critical cloud region reminded us it's a single point of failure. How data, rumor, and politics braided into a single narrative rope. We start with facts, follow the logs and light, and leave with questions intact. Background. The science, 3I/Atlas in a short lineage. Interstellar objects are visitors on hyperbolic paths, not bound to the sun. Oumuamua in 2017, 1I/2017 U1, first of its kind with its light curve puzzles. 2I/Borisov in 2019, a more comet-like body with recognizable gas emission. In mid-2025, the Atlas Survey, Asteroid Terrestrial Impact Last Alert System, flagged an object with a trajectory suggestive of interstellar origin. Within weeks, community follow-up, optical photometry, early spectroscopy, and sparse polarimetry coalesced around a provisional designation, 3I/Atlas. For a public steeped in exoplanet headlines and AI wonder, a third interstellar object was both ordinary and extraordinary. It had a faint coma. It shed volatiles under solar heating. Teams proposed JWST time for spectra in the near and mid-infrared. Ground arrays chased rotation and polarization. Discord servers pulsed with difference curves and residuals. Then came calendar arithmetic. Conjunction. Solar conjunction is geometry. The object passes too near the sun's line of sight. Earth-based telescopes can't observe it. Even space observatories avoid pointing too close to the solar limb. Conjunctions are not conspiracies. They're a truce between safety and curiosity. For 3I/Atlas, the blind window landed between October 21st and early November, depending on instrument constraints. The sky closed. The infrastructure U.S. East 1, the blood vessel. U.S. East 1, Amazon Web Services Northern Virginia region, isn't a single building. It's multiple availability zones, clusters of data centers spread across counties. It hosts compute, storage, DNS resolvers, authentication systems, and managed databases like DynamoDB. It is deeply woven into North American and global application stacks. Dependencies propagate. A small increase in DNS errors can cascade into auth retries, then database throttling. One region's malaise can ripple outward through load balancers and CI pipelines. When US East 1 wobbles, it's like a nerve cluster misfiring. Fingers tingle far from the spine. DNS, domain name system, is address resolution. If resolvers glitch, services stall. Managed key-value stores like DynamoDB are the fast ledgers behind social feeds, tickets, order carts. Authentication services mint and validate the tokens that say, "You are you." Break any link and the chain slows or snaps. On October 20th, US East 1 logged elevated DNS errors around 3:11 a.m. Eastern Time, spiking off latency and, in places, tipping DynamoDB into timeouts. Status pages would later list elevated error rates and partial impact. The cables underfoot, wet fiber and brittle routes. A global cloud rides on cables stitched across oceans and seas. In March 2025, a series of cuts in the eastern Mediterranean, reported along the AAE-1 and a lesser-known CIW-5 segment near the Italy-Greece corridor, forced traffic to reroute. It wasn't catastrophic. Redundancy worked, but latency rose, BGP routes flapped, and the episode lingered in memory. Diagnostics like OTDR, optical time domain reflectometry, help pinpoint faults. Sometimes those look like anchor drags. Sometimes they look deliberate. Either way, they remind us of the physicality beneath our abstractions. The social layer, feeds, lives, and a hashtag. Alternate media outlets, some technical, some performative, cut quick explainer videos about double blindness. Live streamers overlaid AWS graphs with heliocentric schematics. Memes bloomed. A sun wearing an AWS logo, a comet labeled 3I being chased by Auth 500s. The hashtag alien probe trended next to hashtag 3iAtlas. A few accounts claimed metallic emission lines in the spectrum. Others quote-tweeted skeptical astronomers saying, "Slow down." The center battled the edges. Official accounts called for patience. Anonymous posts hinted at laser signatures. The mix was volatile. Enough facts to anchor interest, enough gaps to support fantasy. Timeline. July 1st, 2025, 8:42 Universal Time Coordinated. Atlas flags a fast-moving object on a hyperbolic trajectory. Follow-up scheduled. Atlas site. 2025-07-15, 2025-08-10. Ground-based photometry and early polarimetry suggest dust coma. Preliminary inversion angle estimates emerge. September 19, 2025, 11:03 Universal Time Coordinated. IceCube logs high-energy neutrino event 2550919 A is almost equal to 290 TeV. Directionality uncertain. Chatter notes proximity to 3I/Atlas's Skytrack. September 30th, 2025, JWST NIR spec/Maritime obtained under a director's discretionary window. First spectra pipeline processed by late October. October 20th, 2025, 3:11 Eastern Time, 7:11 Universal Time Coordinated. AWS US East 1 registers elevated DNS errors. Auth latency climbs. DynamoDB timeouts appear in customer metrics. Partial outage noted. October 20th, 2025, 10:45 Eastern Time. AWS status indicates mitigation in progress. Error rates declining. October 21st, 2025, 18:20 Universal Time Coordinated. 3I/Atlas enters solar conjunction constraints for most ground-based instruments. Loss of visual tracking begins. October 22nd, 2025. IAA issues brief noting anomalous polarimetry, pending peer review. Social media amplifies claims of green laser lines, unverified. October 24th, 2025. A European lab leaks a memo about narrowband emission near 532 nanometers. Outlets pick it up without context. October 27th, 2025. UN COPUO schedules an informal consultation. NASA/JWST teams reiterate, wait and verify. Data blocks. Spectrum, JWST, 2025-09-10/10.
Sohao 811.
Notes. Corrected for instrument LSF. Residuals at 2.7 to 4.3 micrometers. Continuum faint. Meaning, elevated CO2 relative to water is unusual but not unprecedented in comets. For an interstellar object, it complicates models of origin. Alt interpretation, calibration or slit loss could bias ratios. Polarimetry, ground. 2025-08-10/15. Inversion angle is almost equal to 17 degrees with large uncertainties. Phase curve atypical compared to solar system comets. Meaning, suggests dust with different grain size/structure. Could indicate unusual composition. Alt interpretation. Sparse phase coverage. Atmospheric systematics. Emission claim. Unverified. October 24, 2025. Narrowband feature at -532 nanometers. Green. Coherent like profile. Possible Ni alloy lines reported by tabloid sites. Meaning, a true coherent narrowband line invisible could hint at laser-like emission, an extraordinary claim. Alt interpretation. Instrumental scatter, auroral contamination, or misidentified telluric line. Lab miscalibration, media distortion. Log, AWS, October 20th, 2025 T 3 hours 11 minutes and 7 seconds Z, US, East, 1. DNS. Next domain spike 98%, auth latency plus 1020 milliseconds, DynamoDB 504 timeouts observed across 2 AZs, meaning resolver failures cascaded into auth slowdowns and DB timeouts, typical of control plane hiccups. Alt interpretation. Could mask targeted attack patterns, but no indicators publicly present. Press, AIAA, October 22, 2025. Current review confirms an anomaly in polarimetry. Spectroscopic features under analysis. We urge colleagues to follow protocol and publish methods. Meaning, signals caution while acknowledging something odd.
Alt-Interpretation, institutional Hedging.
Tweet, at @astro_citizen, October 22, 2025, 1904, Universal Time Coordinated. 3I Atlas CO2, H2O8:1, and a whisper at 532 nanometers? What are we not being told? Hashtag alien probe, hashtag 3I Atlas, meaning public fascination leaps ahead of peer review. Alt interpretation. A meme doing what memes do.
Log, Backbone, 2025-0307T14. 58 Z, AE1/CIW5.
OTDR reflection at 124.3 kilometers off Crete. Attenuation jump suggests mechanical damage near seabed. Repair dispatched. Meaning, earlier in the year, cables reminded us they break. Alt interpretation. Anchors happen, not a plot. Voices. We don't see a mechanism linking a comet and a DNS resolver, says Dr. Anya Drost, a polarimetry specialist at Leiden. Correlation here is a narrative temptation, not physics. Drost's lab contributed to the 17 degrees estimate. She emphasizes how thin the data are near conjunction. Phase angles, calibration stars, weather. Our control plane showed a lock weight on an auth database shard at 309 Zulu, says Ravi Kulkarni, a cloud SRE at a fintech relying on US East 1. Once retries piled, we tripped autoscaling, which tripped throttles. Classic positive feedback. Ugly, but mortal. Kulkarni shows a Grafana panel with a telltale sawtooth. We're evaluating a narrowband feature reported at 532 nanometers, says Dr. Yosef Azrin of the JWST transient team. If it's real, it's not a spectral line we expect from typical cometary processes in that regime. But visibility constraints and instrumental systematics are real. Extraordinary claims, boring pipelines. His email adds 3 attachments: line lists, flat field notes, and a draft methods section. This smells like classification creep, argues Asha Rahman, host of the independent show The Signal Path. Every time sky and cable stories rhyme, we're told to wait for peer review. Meanwhile, plenaries happen off camera. Rahman has a large audience across platforms and a habit of inviting both postdocs and retired colonels. On conjunction windows, we lose leverage, says Matteo Paredes, an analyst at a European space policy think tank. You can't observe, so rumors grow. That's not conspiracy. It's human risk multiplied by comms lag. The forensic week after the double blindness, the hours after October 20th blurred into a pattern of reconstruction. Engineers replaying logs, astronomers recalibrating spectra, policy analysts cross-checking timestamps as if they could stitch causality from parallel threads. By dawn on the 21st, AWS Internal Incident Bridge had grown to more than 400 participants, while the Space Telescope Science Institute spun up an emergency working group labeled 3I Atlas Verification. Both groups, though living in different domains, shared a mantra that week: trace the sequence, separate signal from coincidence, rebuild the timeline without stories attached. The postmortem began with simple data pulls. CloudTrail dumps, DNS resolver metrics, and DynamoDB performance counters poured into forensic buckets. Engineers correlated them with Thousand Eyes network probes and external BGP monitors. A repeating pattern appeared. At 03 to 09 to 58Z, a control plane configuration push to a specific availability zone failed due to a lock wait on an authentication database shard. 2 minutes later, resolver caches filled with next domains. At 3:12, load balancers began draining unhealthy targets. It wasn't glamorous, it was routine chaos. The kind of bug that hides in retry logic until a timing coincidence turns it visible. Maria Camacho, the engineer from the first hour, later described the night as a choreography of timeouts. She extracted the key entries. October 20th, 2025 T3 hours 9 minutes and 58 seconds Z, control plane. Config_push failed SVC, auth, AZ3, timeout. October 20th, 2025 T3 hours 11 minutes and 7 seconds Z DNS resolver. Next domain rate spike 98% regionus, east, 1. October 20th, 2025 T3 hours 12 minutes and 30 seconds ZLB health checker. Unhealthy back-end pool draining. Each line meant latency, not mystery, yet people still searched for pattern because pattern feels safer than randomness. Analysts hunted indicators of compromise, anomalous API calls, off-hour SSH keys, VPC flow logs showing unexpected IP ranges. Nothing fit the signature of an intrusion. The evidence favored internal race conditions amplified by maintenance drift. By October 21st, AWS issued the preliminary verdict. No external attack, root cause, missequenced configuration update under heavy load. But because the same window coincided with 3I Atlas disappearing behind the sun, public speculation ignored the PDF and clung to the symmetry. Meanwhile, network teams looked below the ocean. Mediterranean backbone traffic graphs showed minor rerouting delays through AAE1, consistent with ongoing repairs from the March incident. Submarine cable forensics rely on optical time domain reflectometry, firing light pulses and measuring reflections to estimate distance to fault. The report read, OTDR AAE1, October 20th, 2025 reflection at 124.3 kilometers unchanged. No new attenuation. In plain language, no fresh cuts, no sabotage. Yet latency spikes across southern Europe fed rumor mills that something propagated through infrastructure. To anyone outside network engineering, milliseconds feel like messages. Space-side forensics were slower, ritualistic. JWST's raw frames from late September and early October went through recalibration. Dark subtraction, flat fielding, correction for instrument line spread function. The pipeline at STSCI flagged residuals at 2.7 to 4.3 microns, but none consistent with coherent emission. Dr. Yosef Azran's team reran the spectral extraction using a stricter stray light mask. The supposed green line at 532 nanometers could not have come from JWST at all. It operates in infrared. The rumor originated from a ground-based spectrograph in Tenerife using a high-gain photomultiplier meant for auroral studies. The lab's calibration lamp had a defective filter. When corrected, the narrowband peak dropped into noise. Still, screenshots of the original plot spread faster than the retraction. Polarimetric reanalysis showed that the 17-degree inversion angle remained, though with 40% uncertainty. Dust models suggested large porous aggregates coated with complex organics, a plausible interstellar signature, not evidence of technology. Parallel teams at Cerro Paranal and Mauna Kea prepared to resume tracking once 3I/Atlas emerged from conjunction in November. The neutrino coincidence from IceCube, event 2550919A, was statistically weak. Directional reconstruction placed it 12 degrees off the comet's trajectory, within the background expectation of atmospheric events. Tempting symmetry, but coincidence, wrote Dr. Lena Park in the internal memo. The forensic rhythm extended into correlation analysis. Statisticians attempted to quantify the odds of both incidents overlapping. Global major cloud outages occur roughly 5 times per year. Interstellar conjunctions observable from Earth about once every 5 years. Assuming independence, the chance of both within 48 hours is roughly 1 in 300 rare, but not cosmic. Add the trial factor of thousands of events happening globally each week, and coincidence climbs toward inevitability. Numbers cooled the story, though they couldn't extinguish it. Intelligence agencies entered quietly. Dual-use technologies blur the line between SETI and SIGINT. Optical lasers used for deep space communication resemble line-of-sight targeting systems. Radio SETI overlaps with surveillance spectrums. The U.S. Defense Intelligence Agency requested raw instrument telemetry for calibration validation. ESA's Internal Policy Board debated whether to classify transient narrowband detections until verification. The IAA reminded all members of the no-reply clause. Detection alone does not justify transmission. A short flowchart circulated, detection IAA review UN consultation national briefing if warranted. Bureaucratic caution masqueraded as secrecy. Within agencies, some scientists bristled. Transparency is a security feature, not a risk, wrote one anonymous physicist on an internal forum. Still, the memo chain thickened. Language hardened. Words like potential technosignature appeared with the prefix unverified. Citizen scientists filled the vacuum. Backyard observatories equipped with cheap diffraction gratings and GPS-synchronized photometers streamed data through open networks. An open-source project called SkySync aggregated hundreds of amateur spectra into an AI-assisted classifier running on quantum simulators hosted by Canadian startups. The model flagged dozens of false positives, urban LEDs, airplane strobes, even a glint from Starlink panels. But it also trained the next generation of eyes to look critically. One participant, Sophia Liang from Taipei, said, "We learned calibration is humility. Yet the democratization of analysis brought noise. AI pipelines posted preliminary results without human review, spawning graphs that social media mistook for discoveries. The cycle repeated. Excitement debunk fatigue new rumor. Inside think tanks, analysts constructed likelihood matrices. Each scenario was rated by probability and evidence weight. Coincidence, high likelihood. Routine technical failure, very high. Opportunistic exploit, medium. Cosmic causal link, low. Technological emission, very low but non-zero, because epistemology never allows zero. The matrix was dry, but clarity hides in tables. The pattern that emerged wasn't extraterrestrial intent but infrastructural fragility. A civilization dependent on synchronized systems, both human and silicon, prone to overinterpretation during outages. The AWS postmortem confirmed the control plane misfire. Engineers patched sequencing logic. The STSCI retraction note on the green emission went public in early November, though engagement was minimal compared to the viral thread that birthed it. By then, conspiracy communities had pivoted. Some claimed the retraction was staged. Others argued the signal had been scrubbed. Analysts at the European Center for Cyberinformation noted coordinated amplification from newly registered accounts tracing to ad networks rather than intelligence fronts. Monetization, not manipulation. Still, intelligence briefings treated the overlap as a teachable incident. They outlined steps. Improved cross-domain communication between cloud providers and space agencies, shared incident timestamp repositories, and a proposed international forensic framework for cross-sector anomalies. The irony was that both communities already practiced documentation. They just didn't speak the same temporal language. Engineers think in milliseconds, astronomers in light minutes. The correlation window between their domains will always be metaphorical. In interviews, experts tried to reframe the week. Dr. Anya Drost told Nature, "This wasn't about aliens or outages. It was about how fragile our narratives are when we lose data streams." Maria Camacho agreed from the other side. I fix servers, not stars. But the same bug lives in both. Latency between what happens and what we understand. On October 27th, the UN COPUO's informal consultation met in Vienna. Notes leaked afterwards summarized consensus. Reaffirm the no-reply clause. Encourage data sharing. Caution against premature conclusions. Behind closed doors, however, smaller working groups discussed the cost of blind zones, how losing observation windows, digital or cosmic, undermines public trust. A European delegate reportedly said, "Transparency is not a luxury in the era of viral causality." By the week's end, journalists had cooled the story into retrospectives titled "The Coincidence That Broke the Feed." Yet, under the surface, research continued. At the Jet Propulsion Laboratory, analysts reran models of dust grain scattering to explain the polarimetric anomaly. Their simulations suggested aggregates of metallic sulfides could produce the 17-degree inversion without implying manufacture. At the same time, quantum data analysis startups replayed the AWS logs using anomaly detection models originally built for gravitational wave pipelines. None found external fingerprints, but one flagged a subtle temporal resonance, a 10-millisecond rhythm in request failures. Engineers explained it as retry intervals. Philosophers of coincidence saw poetry. In private Slack archives later released to journalists, one message stood out from Maria to her team. "If anyone asks, tell them we found the bug. If they still ask, tell them we're all bugs running on someone else's timeout." By early November, 3I/Atlas had yet to reappear visually, but radar echoes from solar orbital instruments suggested its trajectory was nominal. The hypothetical laser emission remained unconfirmed. The IceCube team closed their coincidence analysis with a one-sentence conclusion: no statistically significant association found. The cloud outage receded into the background of 1,000 other service disruptions. Still, cross-domain working groups lingered, studying human behavior under simultaneous data loss. Cognitive scientists framed it as a case of narrative convergence under uncertainty, when two unrelated blind spots invite a single myth. A week later, think tank summaries reached similar conclusions but added one policy note: the next time independent systems fail in synchrony, establish a joint task force within 6 hours, before speculation becomes ontology. In the corridors of the International Astronomical Association, someone printed that line on a coffee mug. By mid-month, both AWS and the STSCI released sanitized timelines, and the media cycle moved on. Yet analysts kept returning to the phrase green laser. Even disproven, it acted as a thought experiment. What would coherent emission from an interstellar object mean for diplomacy, ethics, existential protocol? The debates in ethics seminars outlived the data itself. An internal NASA think piece, Communication Without Sender, circulated among policy circles, arguing that the greater lesson was epistemic discipline, learning to say "we don't know" without filling the silence with fear or fantasy. In that silence, however, others heard opportunity. Private startups announced technosignature early warning systems, AI-driven platforms promising to detect laser-like emissions and monetize alerts. Investors loved the narrative, not the data. A year later, one of those systems would falsely flag a laser from a coastal wind farm. But that, as an engineer later quipped, was another story. The closing week of October left a residue of humility across both domains. Logs were cleaned, spectra reprocessed, policies rewritten. But the core unanswered question remained: why does coincidence feel like communication? For now, all that was left was the hum of servers and the faint static of cosmic background noise. Somewhere, beyond the sun, 3I/Atlas continued its indifferent path, and deep beneath the Antarctic ice, IceCube kept listening for neutrinos that might someday line up with light and myth. The postmortem, stamped and archived, ended with a single line: incident resolved, root cause verified, public fascination ongoing. Yet among those who had stared at failing dashboards or noisy spectra that week, resolution felt provisional. They knew that every explanation is a temporary service restoration. And so, as November approached and telescopes prepared for reacquisition, a quiet anticipation spread, not of aliens or outages, but of data itself returning, of the human need to look again. Would the next frames show the same spectra? Or would something have shifted in the intervening solar shadow? No one could say. The waiting was the method. The day the story went public on October 28, 2025, 8 days after the double-blind window, the world stopped whispering in private group chats and began shouting in public hearings. The scientific silence that had once protected patients was broken by politics, economics, and the algorithmic hunger of modern news cycles. By then, AWS had published a 37-page incident report. JWST teams had issued 3 technical notes. The IAA's statement about anomalous but unconfirmed polarimetry was still pinned on their front page. And yet none of it mattered, because the public imagination had already built its own truth, that a green light had been seen across the void, and that governments were hiding what it meant. The first official reaction came from NASA Administrator Elena Porter. At 9 o'clock Eastern Time, she faced reporters at the James Webb Operations Center in Baltimore. Cameras flashed, live captions scrolled. "There is no evidence of technological emission," she said calmly. "Our instruments observed normal cometary spectra. The green line reported last week was not corroborated by space-based assets." A hand rose. "Then why classify parts of the JWST telemetry?" Porter hesitated for a second, as if considering the weight of each syllable. "Telemetry data can contain proprietary calibration patterns and spacecraft health information. It's standard practice." The clip circulated instantly. Within minutes, the phrase proprietary calibration patterns was trending, interpreted as coded language for censorship. The European Space Agency held its own press briefing 2 hours later, emphasizing cooperation and transparency. "We are sharing all optical data within international review networks," said ESA Science Director Dr. Lorenzo Vitali. "Extraordinary claims require extraordinary care." But even as he spoke, the UK tabloid Daily Sentinel published a leaked memo titled 532 nanometers Signal Internal Note. The document, partly authentic, partly fabricated, claimed the line was consistent with coherent photonic emission. By noon, U.S. senators were calling for a congressional hearing. The Department of Defense added fuel by issuing a cautious remark that any anomalous signal of possible non-terrestrial origin falls under the joint jurisdiction of defense and scientific authorities. Markets reacted. Small aerospace stocks surged. Cybersecurity indexes fell. Twitter, now renamed XNet, exploded. Hashtags #GreenlineGate and #AtlasSignal climbed past global sports events. One viral post read, "First they lost the cloud, now they lost the sky." The mixture of sarcasm and suspicion was irresistible. Governments scrambled to manage the optics. In Washington, the White House press secretary stated that the administration remains committed to open science, and that the president has been briefed and sees no cause for concern. In Beijing, the China National Space Administration hinted that its Chang'e 7 lunar array had detected no anomalies, but added, further data will be shared through the United Nations framework. Moscow's Roscosmos chose silence. The Russian foreign minister instead accused Western networks of narrative manipulation. Within days, the issue reached Vienna. The UN Office for Outer Space Affairs called an emergency COPUOS session titled Potential Implications of Transient Technological Emission Reports. Delegates from 39 member states joined physically, another 40 through encrypted teleconference. The agenda mixed physics and diplomacy. An observer described the atmosphere as half scientific workshop, half geopolitical theater. The US and EU delegations urged caution. Verification precedes interpretation. China pushed for stricter data retention and central coordination. A joint India-Brazil proposal called for a public repository of raw astronomical telemetry, accessible through a UN-managed server. No resolution passed, but a communiqué reaffirmed the no-reply clause and the principle of unprovoked silence toward unverified extraterrestrial sources. That single phrase, unprovoked silence, became the headline for most international papers the next day. Meanwhile, the media ecosystem turned the technical details into spectacle. On YouTube, live-stream debates with titles like Alien Signal or Human Error.
Drôle million.
Memes of green lasers hitting Earth flooded Reddit. Talk show hosts joked about cosmic Wi-Fi. On the serious end, The Atlantic published a long-form piece titled Our Need for Patterns, connecting the incident to pandemic-era misinformation and the psychology of uncertainty. But even reasoned commentary couldn't stop the acceleration. When facts compete with fear, fear wins clicks. By November 1st, several parliaments had called public hearings. In Washington, the House Committee on Science and Technology convened a session streamed live to 12 million viewers. 3 experts testified: Dr. Porter from NASA, Ravi Kulkarni from AWS, and Dr. Anja Drost, the Dutch polarimetry researcher. The hearing opened with Representative Aaron Delgado holding up a printed tweet. "Doctor, if this is fake, why did so many instruments register anomalies at the same time?" Porter replied, "Because the same geometry affected both sky and system, solar conjunction and software maintenance. Coincidence is the default, not conspiracy." Delgado smiled. "And yet people don't believe coincidences that cost billions." The quote became an instant headline. That same week in Brussels, the European Parliament held its own debate on digital infrastructure sovereignty. While nominally about cloud resilience, the session kept drifting back to 3i/Atlas. "We trusted one company's region for half of Europe's authentication traffic," said MEP Isabel Charvet. "When it went dark, rumors filled the gap faster than data could recover." The lesson was clear: narrative latency is now a security risk. Across the Atlantic, think tanks began publishing position papers. RAND issued coincidence cascades, socio-technical lessons from 3i/Atlas, arguing for cross-sector crisis protocols between astronomy, cybersecurity, and communications. Chatham House released The Green Line Effect: How Data Gaps Breed Geopolitics. Both documents landed on policymakers' desks before the week's end. Citizens followed their own logic. Amateur astronomers uploaded every raw frame they had collected before conjunction to open repositories. AI collectives trained models to detect artificial modulation in noise patterns. The models predictably found patterns everywhere: satellite glints, cosmic rays, even JPEG compression artifacts. Each false positive reignited speculation. In response, the International Astronomical Association launched a public data verification task force, urging responsible curiosity. Yet, outside academia, the signal was now a cultural phenomenon. Musicians sampled 532 nanometers in song titles. Streetwear brands printed green diagonal lines on t-shirts with the caption "Blind Spot 2025. Netflix commissioned a docudrama called Atlas: The Day We Looked Away. By November 5th, even people who had never read a scientific paper could quote the incident's timestamp, 3:11 Eastern Time. The deeper tension lay between governments and transparency advocates. Several leaks suggested that parts of JWST's telemetry were withheld not for proprietary reasons, but because they contained navigation vectors that could reveal satellite orientation, classified under international space law. A joint European committee recommended releasing anonymized segments, but defense advisors objected, citing potential dual-use exploitation. Inside NASA, internal emails leaked to The Intercept revealed frustration. "We're scientists, not gatekeepers," wrote one researcher. Another replied, "Try telling that to the Defense Subcommittee." In Beijing, a different narrative thrived. State media portrayed the Western confusion as proof of information chaos and announced plans for a Sino-Russian deep space observatory that would avoid reliance on Western data infrastructure. The same evening, the U.S. Department of Commerce held a confidential meeting about data localization and multi-cloud redundancy. Political polarization found fertile ground. In the U.S., talk show hosts split along predictable lines. Some mocked the alien truthers, others accused NASA of lying. In Europe, populist parties used the event to call for digital independence from U.S. hyperscalers. The phrase sovereign cloud entered the lexicon of politics. Meanwhile, the general public oscillated between fascination and fatigue. Sociologists at the University of Oxford tracked sentiment analysis across 20 million posts. They found a predictable decay curve. Outrage peaks within 48 hours. Irony follows by day 5, apathy by day 10. Yet the green line persisted longer than any meme in recent memory, perhaps because it offered hope as much as fear. On November 10th, the UN released a technical annex from its Vienna session. Buried in the appendix was a small note. No confirmed signal at 532 nanometers has been verified by independent instruments as of this date. It should have ended the debate. But a popular influencer twisted the phrasing, claiming, "They admit it was real once." That night, AWS Chief Technology Officer appeared on 60 Minutes to explain their own coincidence. "The outage wasn't caused by cosmic rays," he said, half smiling. "It was caused by humans, which is scarier." His candor resonated. Within days, the narrative started shifting from extraterrestrial speculation to terrestrial fragility. Think tanks reframed the event as a wake-up call for digital dependency. A report from MITRE summarized it best. "A society that cannot distinguish between infrastructure failure and existential signal has a reliability problem, not a cosmic one." Despite official reassurance, diplomacy continued behind closed doors. Unconfirmed reports suggested that the United States, China, and the EU exchanged technical data through a Track 1.5 channel, mediated by neutral Switzerland. The goal was simple: verify that none had spoofed or misinterpreted the alleged emission. In Geneva, a smaller symposium convened under Chatham House rules. There, scientists, philosophers, and intelligence officers shared a table. According to an attendee's later memoir, the atmosphere was tense but strangely hopeful. Everyone wanted the signal to be real. The memoir read, "Because a real mystery feels better than human error." The cultural aftermath deepened. Universities launched courses titled Information Epistemology in the Age of Outages. Artists projected green light beams into city skies. In Tokyo, a museum exhibit called The Blind Zone simulated the feeling of losing all data feeds for 60 seconds. Visitors described it as unsettlingly peaceful. As the second week of November ended, new developments brought a fragile calm. 3I/Atlas began to emerge from behind the sun. Observatories in the southern hemisphere captured its faint coma again. No laser, no abnormal emission, just the same interstellar traveler continuing its arc through space. Dr. Drost published a brief note. "The object's behavior remains consistent with natural models. The green line was not detected." Few noticed. The internet had moved on to other controversies. But for scientists, relief mingled with regret. In a final press conference, Dr. Porter summarized the ordeal. "We confirmed the ordinary and lost the extraordinary." In Europe, ESA quietly uploaded the full spectral dataset to a public FTP server. Downloads numbered in the hundreds, far less than the millions who had shared conspiracy videos. By then, the world's attention had fragmented, yet inside agencies and think tanks, the lessons remained. The first was infrastructural. Diversify critical systems, reduce single-region dependencies. The second was communicative. Build frameworks for synchronized public messaging between technical and political institutions. And the third was psychological. Teach society to tolerate uncertainty without defaulting to mythology. On November 15th, the final UN communiqué on the incident was released. It contained 3 sentences that summed up a global mood. The events surrounding 3I/Atlas and the October 2025 outage demonstrate the interconnected vulnerability of observation and communication. Scientific integrity requires transparency. Public trust requires restraint. We must learn to coexist with temporary blindness. In the days following, a quieter conversation began in private forums, among scientists, ethicists, and journalists. They asked what the event truly revealed. Not aliens, not sabotage, but the limits of human patience. The internet had taught humanity to expect instant answers, yet the universe operated on light minutes, not megabits. The closing metaphor came from an unexpected source, a cloud engineer from AWS who wrote on his personal blog, "In every outage, there's a period when monitoring graphs go flat. We call it the silent window. You can panic or you can breathe. The universe has its own silent windows. We just experienced one together." The post went viral not for its technical depth, but for its humility. As December approached, the world had largely moved on. 3I/Atlas drifted outward. Another faint speck cataloged and archived. AWS patched its code. Scientists resumed their routines. But for those who lived through the double blindness, a subtle shift remained. They understood now that information isn't infinite. Sometimes it bends, breaks, or disappears, just like light. The next anomaly, whenever it came, would meet a slightly wiser, slightly warier world. Or perhaps not, because as one observer from the Vienna session later joked, human memory has a short half-life, shorter even than DNS TTLs. And somewhere, far beyond the sun's glare, a faint green reflection still flickered in archived pixels. Forever ambiguous, forever human. By December 2025, the noise had faded, but the internal machinery of inquiry had only just begun to move. The public's obsession with the green laser burned out in a few weeks, but inside the world's major scientific and intelligence institutions, the echoes of that week in October refused to die. Every agency involved, from NASA and ESA to the UN Office for Outer Space Affairs, had opened parallel investigations, each convinced the key to understanding wasn't in the stars but in the systems that looked at them. At NASA, a special task group called Atlas 3I Review Board was assembled at the Goddard Space Flight Center. 12 people. Astronomers, software engineers, a cyberforensics expert from DARPA, and an observer from the National Science Foundation. Their mission statement, printed in precise sans serif on a single sheet, evaluate the technical integrity, communication protocol, and cross-domain data handling related to the 3I/Atlas incident and the AWS infrastructure failure of October 20, 2025. It sounded procedural. It wasn't. Dr. Elena Porter chaired the board. Her first words at the opening meeting were simple. The data itself never lies, but the order in which we reveal it can create new truths. A projection screen displayed the entire timeline from September through November. Every event, every press release, every rumor plotted like constellations in a chaotic sky. Across the room, pinned on the wall, hung printouts of JWST spectra with color-coded annotations. One section, circled in red, showed the now infamous dip near 532 nanometers, the supposed laser. Next to it, handwritten in black marker, artifact, not anomaly. The board's work quickly split into factions. The scientists focused on calibration, atmospheric contamination, and instrumental noise. The engineers focused on code, specifically how pipeline versions and timestamp synchronization could have produced phantom features. The defense observer, Colonel Lydia Mercer, had a different concern. Public communication latency, she said during one session. It's the most dangerous variable. If information lags by 12 hours, misinformation fills the gap in two. Their investigation produced revelations few outside the room ever heard. One line in the JWST data showed that the stray light correction file used in the Tenerife Labs instruments had been compiled from an outdated model, an error traceable to an automated update server that had failed to synchronize during the AWS outage. In other words, the same technical event that froze authentication requests may have also delayed calibration file propagation across mirrored repositories. A subtle, almost poetic coincidence. The cloud outage may have indirectly created the ghost of the green laser. Log 2025-10-20T03:09Z sync node EU West 2 replication delay 92M. Log 2025-10-20T03:11Z checksum mismatch on file strakel_v4.fits. Note, reverted to cached version, dated September 5, 2025. Dr. Porter read the line twice, her face impassive. That's the ghost, she said softly. Not aliens, latency. But not everyone agreed. Dr. Rajesh Kulkar, the spectral analyst, cautioned against closing the case too quickly. It explains the feature, he said, but not the amplitude. We still have a residual peak above instrument noise. The argument lasted 2 hours. Eventually, the board agreed to categorize the line as instrumental artifact, residual uncertainty 8%. That single percentage kept the mystery alive in internal memos for months. While Goddard debated photons, Another inquiry unfolded at AWS headquarters in Seattle. The Infrastructure Resilience Division conducted a full postmortem of the postmortem, auditing every decision made between 3 o'clock and 11 o'clock Eastern Time on October 20th. Their findings were candid. AWS Internal Report Excerpt. Root cause: configuration propagation error triggered by control plane overload. Contributing factors: uncoordinated maintenance windows between regions. Legacy dependency on central auth database. Deprecated, not fully detached. Underestimated exponential retry load during partial degradation. Mitigation: increased back-off intervals, region isolation testing, review of DNS resolver redundancy. The engineers concluded there was no external intrusion. But they also noted something else. The control plane failure caused minor timestamp drifts across dependent services. One engineer described it as digital vertigo, a few seconds of temporal disalignment across thousands of machines. If synchronized instruments were pulling calibration data at that precise moment, subtle offsets could have propagated into scientific pipelines downstream. A metaphorical butterfly effect, with the flap of a virtual server causing a flicker in a cosmic graph. Meanwhile, in Geneva, the European Space Policy Institute held closed-door consultations. Attendees included representatives from ESA, the French NIS, and Germany's DLR. Their agenda: strategic autonomy in scientific verification. The meeting notes, later leaked, revealed growing tension between scientific independence and national security interests. The more we rely on global cloud platforms for raw data storage, said one delegate, the less sovereign our discoveries become. In a parallel conversation, the UN Office for Outer Space Affairs prepared a confidential report summarizing internal consultations after the October 27 COP session. It concluded that member states acknowledge the necessity of establishing shared verification frameworks for transient astronomical phenomena potentially interpreted as technosignatures. The phrase "potentially interpreted" was carefully chosen. Lawyers had argued for 3 days over whether to use allegedly detected or publicly claimed. Semantics were diplomacy's defense mechanism. At the same time, inside the ESA Technical Directorate in Noordwijk, Netherlands, a smaller conflict brewed. Young researchers wanted the 532 nanometers raw frames released immediately, believing that public scrutiny would restore trust. Senior administrators refused, citing confidentiality clauses in the JWST-MIRI partnership. A tense email exchange summarized the generational divide. Email from Dr. Elise Brandt to ESA Exec Board. Date: December 8, 2025. Subject: Re-release of 532 nanometers dataset. If we keep treating data as dangerous, we make ignorance the default. The best way to fight conspiracy is exposure, not embargo. Reply from Director Vitali. Transparency is a virtue until it becomes an attack surface. That phrase, attack surface, would later appear in at least 3 policy papers about data governance. The inquiries stretched beyond institutions into philosophy. Universities held symposiums titled Epistemology in the Age of Outage. One at MIT brought together engineers, astronomers, and psychologists. A keynote by Dr. Marta Liu, a cognitive scientist, defined the incident as a mass epistemic cascade. When 2 systems, cosmic observation and digital infrastructure, fail simultaneously, she said, humans interpret coincidence as message, its pattern seeking as a survival reflex. Her talk went viral among academics, quoted more than any official report. In late December, internal conflicts reached a breaking point at NASA. The Defense Science Board representative pushed for partial classification of the residual data, arguing that even unverified anomalies could be exploited by adversarial state media.
Docteur Porter résistait fiercely.
We cannot classify uncertainty, she told them. If we do, we teach people to fear ambiguity. The vote that followed was close, 6-5 against classification. The minutes of that meeting, released months later, showed the intensity of the debate. The scientists won by 1 vote. Elsewhere, less visible investigations continued. At the Jet Propulsion Laboratory, A secret subproject called EchoMap began correlating every historical case of simultaneous infrastructure outages and astronomical anomalies since 1990. The dataset included the 2003 North American blackout, the 2011 solar flare disruptions, and the 2021 Facebook DNS collapse. The goal was to build a probabilistic model of coincidence clustering. Early results were revealing, roughly every 3 years, at least one pair of unrelated but temporally adjacent anomalies triggered global misinformation spikes. The pattern, wrote the lead analyst, is not cosmic, it's cognitive. Back in Washington, policy circles debated legislative responses. The Senate Committee on Science proposed the Transparency and Verification Act, which would mandate public release of any data used in claims of extraterrestrial or astrophysical significance within 72 hours, barring security risk. Lobbyists from major cloud providers pushed back, fearing legal liability. The compromise draft created the concept of cooperative mirrors, redundant, open repositories maintained by universities, but synchronized with government archives. It was the first legal framework born from the 3i/Atlas event. Public attention was waning, but leaks kept reigniting it. In January 2026, The Guardian published extracts from the NASA board's interim report. A network synchronization delay between distributed calibration servers may have indirectly influenced spectral artifacts. Though accurate, the nuance vanished in translation. Headlines screamed, "NASA confirms cloud glitch created alien signal." Dr. Porter sighed when she read it. "We fixed the data," she told a colleague, "but not the headlines." By February, all 5 major inquiries, NASA, ESA, AWS, UN, and the U.S. Defense Review, had delivered preliminary findings. None mentioned extraterrestrial intelligence. All pointed to infrastructure fragility and the psychology of speculation. Yet one annex buried deep in the UN report hinted at something more abstract. The epistemic cost of simultaneous uncertainty events remains poorly understood. In simpler words, humans struggle when 2 trusted systems fail together. Inside the International Astronomical Association, a different tension surfaced. The SETI Research Coordination Group wanted to integrate technosignature protocols into future observation campaigns. The traditional astronomy division resisted, fearing mission creep and funding diversion. The debate turned personal. One veteran astronomer reportedly said, "We study physics, not philosophy." A younger researcher replied, "You can't separate them anymore." Meanwhile, data scientists continued refining the polarimetric models. Using new simulations on European quantum clusters, they concluded that the 17 degrees inversion angle of 3i/Atlas could be explained by dust grains with nickel-rich cores, metallic, yes, but naturally occurring in interstellar environments. The result removed the last physical need for a manufactured explanation. The final technical memo, published quietly in March 2026, closed the scientific case. The political one remained open. Behind closed doors, intelligence communities continued discussing dual-use implications. Optical laser emissions, even if natural, provided a cover story for future classified communication experiments. In early 2026, a consortium of agencies drafted a confidential guidance note titled Optical Transient Management. Its core message: treat all unverified optical signals as both scientific opportunity and national vulnerability. That dual framing, science and threat, ensured the legacy of 3i/Atlas would live longer in bureaucracy than in astronomy. By spring, the internal conflicts began to ease. Dr. Porter, preparing to retire, gave a private talk at the National Academy of Sciences. Her remarks were not recorded, but attendees reconstructed them from notes. "The green laser," she said, "wasn't a hoax. It was an echo, a byproduct of how our systems see. In a networked civilization, perception is distributed. Every glitch, every delay, every calibration drift becomes part of the collective sensorium. The universe didn't send us a message. We sent one to ourselves, and it said, 'Check your synchronization.'" Her words circulated through scientific circles like quiet scripture. A week later, the AWS team published a technical paper co-authored with NASA engineers, "Cross-Domain Synchronization and the Epistemology of Outage Events." The abstract was almost poetic. Simultaneous data blind spots across physical and digital domains create emergent myths faster than evidence can resolve them. By mid-2026, reforms began. ESA adopted a policy of redundant calibration mirrors across continents. AWS introduced observational priority zones, service tiers guaranteeing synchronization for scientific users even during maintenance. The UN COPUOS formalized a multi-domain event coordination protocol, ensuring that if space and network anomalies coincide again, a joint statement is released within 24 hours. Humanity, in effect, had learned to manage coincidence. Yet beneath the procedural calm, unease persisted. Scientists privately admitted that they missed the mystery. The possibility, however unlikely, that something out there had spoken first, even accidentally, had electrified their work. When certainty returned, it felt like a loss. In late 2026, at a conference in Geneva titled Blindness and Signal, The Legacy of 3I/Atlas, Dr. Anya Drost summarized it perfectly. "We solved the puzzle," she said, "but not the emotion it left behind. The story, stripped of speculation, ended where it began, with light and latency. The forensic boards closed their files, but the lessons bled into disciplines beyond astronomy: information theory, policy design, cognitive psychology. The 3I/Atlas incident became case study material for future generations, an example of how knowledge falters not from ignorance, but from synchronization drift between truth and trust. Somewhere, the interstellar object continued its silent journey outward, unbothered by the dramas it had triggered. No signal, no intent, only motion. Yet in human memory, it lingered, a ghost not of aliens, but of our own reflection flickering in data streams. The inquiry ended not with revelation, but with a simple entry in the final NASA log. By the spring of 2027, the 3I/Atlas episode had been archived in most databases, boxed neatly into science history as a coincidental dual anomaly. Yet, outside the bureaucratic files and quiet scientific journals, its resonance continued. In academic halls, classrooms, podcasts, and policy boards, the phrase double blindness had become shorthand for a generation's most paradoxical truth: that the more connected civilization becomes, the easier it is for it to misread itself. At the Jet Propulsion Laboratory, a small interdepartmental conference titled The Lessons of the Blind Window gathered physicists, engineers, data scientists, and one sociologist. The moderator, Dr. Raphael Kim, opened with a slide showing two flat lines, one from AWS uptime graphs at 3:11 Eastern Time, the other from a telescope photometric trace that same morning. "Both are absences," he said. "One is human, one is cosmic. We learned that we react to both with the same nervous system." The audience laughed, but the room felt heavy. Over the next 3 days, 28 papers were presented, half technical, half philosophical. All circled the same question: what happens when truth itself inherits latency? NASA's Atlas 3I Review Board had been dissolved a year earlier, its findings published in a sober 246-page report that few outside research circles read. The key sentence, buried on page 142, was the epitaph for an era. No evidence of intentional emission or artificial signal was found. Observed anomalies were consistent with synchronization delays and calibration artifacts. Yet in public discourse, that sentence never took root. For the general population, the myth had already supplanted the mechanism. By now, hundreds of small think tanks had sprouted around the world, blending astrophysics, media theory, and social trust studies. One of them, the Global Institute for Information Integrity, published a white paper in 2027 titled When Systems Dream Together. It argued that the 3I/Atlas event marked the first civilizational hallucination, a moment when global networks, instruments, and minds collectively mistook noise for signal. "We witnessed," it claimed, "a species seeing its own infrastructure mirrored against the stars and calling it communication." The phrase would later appear in university curricula, quoted in sociology, not astronomy. In parallel, the technological legacy of the event matured into policy. The UN's multi-domain event coordination protocol, approved in early 2026, had now been tested twice. Once during a global geomagnetic storm, once during a temporary satellite downlink glitch. Both times it worked, Within 3 hours, joint statements were issued by the IAA, AWS, and national observatories preventing conspiracy flare-ups. It was bureaucratic, inelegant, but effective. Humanity had learned to synchronize its story. Still, the cultural undertow was stranger. Art responded faster than science ever could. In Berlin, an exhibition titled 532 nanometers. The color of doubt projected a single green beam through fog into an empty gallery, accompanied by a sound installation looping fragments of the AWS outage logs. In New York, the filmmaker Lee and Sue released Conjunction, a feature-length documentary blending real footage, dramatizations, and synthesized dialogue based on leaked emails. It ended with the voice of Dr. Porter reading a line that had never been spoken publicly. "Every time we fail to synchronize, the universe tells us we're still human." The quote wasn't hers, but it felt right. The film reignited discussion online, resurrecting the old hashtags #Greenline and #3iAtlas. Old debates flared again, half nostalgia, half skepticism. But this time, the tone was softer, more reflective. Even the loudest conspiracy figures had grown weary. The myth, domesticated by time, had become metaphor. Inside NASA, Elena Porter, now retired, had begun writing a book titled The Sky Behind the Firewall. It was part memoir, part essay, part apology. In an early chapter, leaked to The Atlantic, she wrote, "We wanted proof of something extraordinary, and when nature offered us latency instead, we filled the silence with imagination. That was our real experiment." Her words resonated far beyond the scientific community. They were quoted in think pieces, sermons, and startup manifestos. Porter never finished the book. She died quietly in late 2027, weeks before The Sky Behind the Firewall went to print. The final line of her draft read simply, "Blindness is not ignorance. It's the price of attention." The release of her unfinished manuscript became a cultural moment. Bookstores filled windows with green-tinted covers. Universities held memorial panels, and the media briefly rediscovered the event it had once sensationalized. For a week, the words 3i/Atlas trended again, not as mystery but as lesson. Meanwhile, the scientific story took one last turn. In early 2028, the ESA-led mission Gaia Plus, an upgraded astrometric satellite, released new data that included refined tracking of interstellar objects. Among them was 3i/Atlas, now receding toward the outer heliosphere, faint but measurable. Its spectral slope had flattened, its coma dispersed, its rotation irregular but predictable. The final report classified it as likely natural, composition consistent with CO2-dominated ice and nickel-bearing dust. Yet one sentence in the data summary caught attention: "No optical emission detected at 532 nanometers above instrument noise." A full-circle confirmation, an ending written in the language of evidence. Dr. Anya Drost, now heading the International Polarimetry Network, summarized the finding in a press release. 3i/Atlas left us with questions about ourselves, not about space. The universe didn't blink. We did. Her measured tone marked the closure of the scientific file, but in the echo chambers of culture, closure was impossible. By then, a new generation of scientists had entered the field, students who were in high school when the event happened. For them, 3i/Atlas wasn't trauma or triumph. It was curriculum. They spoke of it like historians speak of Apollo, a turning point between innocence and discipline. Many were drawn to interdisciplinary research, combining astronomy with information theory, psychology, or ethics. The old walls between sciences had weakened, replaced by shared humility. In Silicon Valley, the incident became a case study in reliability engineering. Cloud architects cited the AWS outage in keynote presentations as the example of correlated failure risk. Some even adopted informal rituals. A moment of silence at 3:11 Eastern Time every October 20th, a tradition they called Sync Pause. What had once been a symbol of chaos became a mantra for resilience. But while infrastructure adapted, geopolitics remained fragile. The UN's coordination framework had succeeded, but cooperation was thinning. Rising global tensions, economic downturns, regional conflicts, the reemergence of cyber proxy wars, turned the once shared fear of cosmic mystery into something more territorial. In 2028, China and Russia jointly announced Project Typhon, a classified optical surveillance satellite for planetary defense. Analysts quietly suspected it was also designed to capture deep space laser communications, real or imagined. In response, the European Union proposed MirrorNet, a decentralized data relay system designed to prevent any single nation from monopolizing cosmic telemetry. The ghosts of 3I/Atlas had migrated into policy. Meanwhile, a quieter transformation unfolded in education and culture. High school science curriculums across several countries introduced a unit titled the 3I/Atlas event: Science, Society, and Synchronization. Students studied not just the astrophysics but the sociology, the viral memes, the misinformation arcs, the institutional responses. The goal was clear: teach skepticism without cynicism. In classrooms from Tokyo to Toronto, teachers repeated the same refrain: a glitch is not a conspiracy. Yet somewhere in the background, one question lingered. If the signal had truly been just an artifact, why did it affect humanity so deeply? The answer, some argued, lay not in the data but in timing. It had occurred at a moment of collective vulnerability, the end of the pandemic era, the rise of AI distrust, the fatigue of constant crisis. The green line had become the perfect mirror for a species desperate to believe that someone, somewhere, might still be trying to reach out. In 2029, a decade-defining book attempted to capture that sentiment. Written by journalist and technologist Simon Arendt, The Coincidence Machine became an international bestseller. It traced the entire chronology, from the first AWS alert to the final UN communique, and wove it into a narrative of human self-reflection. We live, Arendt wrote, in a universe indifferent to us, yet we build systems so complex they begin to echo our longing. When those systems fail, the echo sounds like a voice. His conclusion was haunting. The signal we mistook for extraterrestrial was our own infrastructure whispering, "You're not synchronized." The final scientific closure came quietly, almost anticlimactically. In mid-2029, the International Astronomical Union held its triennial assembly in Cape Town. A short paper was presented during an afternoon session: reanalysis of the 3I/Atlas conjunction spectra with updated calibration models. The conclusion: no coherent emission, no unexplained residuals. The artifact had been entirely reproduced in simulation by injecting a 0.3-second timing offset in the Tenerife spectrograph pipeline. The audience applauded politely. The myth, at least scientifically, was over. But that same evening, at a public outreach event outside the conference hall, children lined up to peer through telescopes aimed at Jupiter. One of them, a girl no older than 10, asked the astronomer, "Is there really a comet that blinked at us once?" The scientist smiled. "Maybe not," he said, "but we blinked at it." In the following years, that line became the title of countless essays, artworks, and retrospectives. We blinked at it. The incident evolved from scandal to parable, from anxiety to humility. It became, in hindsight, the moment humanity rediscovered the fragility of its perception. In 2030, the UN Office for Outer Space Affairs published the final Global Lessons Report. It opened with a sentence that could have closed every chapter before. 3I/Atlas taught us that truth moves at the speed of verification, not virality. The document included 27 recommendations, from distributed data infrastructure to cross-disciplinary ethics councils. But its final page bore a single handwritten note, scanned from Dr. Porter's archives: "The next time the universe goes quiet, listen harder, not faster." As the years passed, the world faced new anomalies, new crises, new signals both terrestrial and cosmic. Yet each time, institutions reacted with a little more patience, a little less panic. The cultural immune system had strengthened. The double blindness had inoculated humanity against its own reflexes. And somewhere beyond the orbit of Neptune, 3I/Atlas kept moving, a dim, cold ember crossing into interstellar space. No light, no laser, no signal, just a trajectory. A faint reflection in humanity's memory. In 2032, the ESA probe Helios Pathfinder captured a final image, a streak barely above background noise. The accompanying press release was brief. 3I/Atlas observed at magnitude 32.2, outbound velocity consistent with 36 kilometers per second. No anomalous emission detected. The last sentence, clinical, precise, carried a quiet poetry. Humanity had looked, learned, and finally let go. A decade later, historians would mark the incident not as an astronomical discovery, but as a cultural one. The moment Earth realized that meaning and noise are twins, forever intertwined. The blind spot had become a mirror, and as the world's telescopes turned toward newer mysteries, the faint whispers from exoplanet atmospheres, the neutrino bursts from distant quasars, somewhere, in the background of every analysis, one question still hovered unspoken. When the next silence comes, will we listen differently? No one could say. But if 3I/Atlas had taught anything, it was that every act of observation is also an act of faith. In the final archived log of the IAA, filed under closed incidents, 2025 to 2030, a single note remains attached to the record.